work. So here we go. Let's go ahead. Each one of these little points is known as a lattice point in the field. Do you have to know that? No, you don't. But if you talk to a professor, like, oh, so what do I do with these lattice point? That's what it's called. It's a lattice point. If you want to Google it later on, it says, all right, guys, focus, focus. It says draw a slope field for each of the following differential equations. Each tick mark is 1 unit. So the tick marks are called lattice points. So it says here that my slopes behave like x plus 1. So the y does not influence them. So that means on the y-axis, the x value is always 0. What is 0 plus 1? 1. So draw a little slope of 1. 1, 1, 1, 1, 1. Do you guys see what we did? Just a little, almost like a tangent line. Just draw a little segment with a slope of 1 on that lattice point. All right, so check it out. I'm going to make it easy for everyone. I'm at the x equals -1 coordinate. I'm at -1, 0. What's -1 plus 1? 0. So on x equals -1 on all those lattice points, you put a slope of 0. See? Do you guys see what's going on? No? All I did was -1 plus 1, and that's 0, and dy dx is slope, so I just draw a little segment with a slope of 0. At -2, that's -2, 0. -2 plus 1 is -1. So you just draw a little slope of -1. Doesn't have to be perfect. -1, -1, -1, -1, -1. Doesn't have to be perfect. At x equals -3, -3 plus 1 is -2. So, Chav, how am I going to do a slope of -2? Are they going to measure it? It doesn't have to be perfect. Make it steeper in the negative direction. Steeper, negative direction, steeper, 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 steeper. There it is. Steeper than the previous one in the negative direction. And there it is. Well, we haven't finished it. We still got three more columns of lattice points here. All right, at the point 1, 0, what's 1 plus 1? 2. So just make it steeper than the y-axis. See, doesn't have to be perfect, guys. Just make it steeper. And then at x equals 2, 0, 2 plus 1 is 3. So make it steeper than the column that you just created. And then at x equals 3, 3 plus 1 is 4. Make it steeper than the other one. Just don't make it practically vertical. Just don't make it vertical because it's not a vertical line, right? And there it is. There's your slope fields, your first slope field that you've drawn. What do you guys think? Not bad, right? Yeah. All right, go to number 2. I'm going to change my colors to blue. On the x-axis, that's dy dx's slope. This one is only affected by the y value, not the x. On the x-axis, your slope is always 0. So 0. Oh, I can't see the blue. Let me go back to red then. 0, 0, 0, 0, 0, 0, 0. If I'm above the x-axis, my slope is positive. So at the y equals 1 line, 1 times 2 is 2. So I'm going to make my slopes of 2. They don't have to be perfect, guys. No one's going to measure you to see that you have the slope of 2. And then the one on top of that, steeper slopes of 4. So just make it steeper. There it is. If you're below the x-axis, I'm at the y equals -1. 2 times -1 is -2. So try to make it the same steepness as the line y equals 1, just negative. Same steepness, just negative. And then at the -2 one, go -4 at the y equals negative. So more steeper. Steeper in the negative direction. And there it is. You just did 2 of them now. What do you guys think? All right, let's go to the next one. Number 3. Chav, this one says x plus y. We're going to go slow. We're going to go slow with this one. The easiest way to teach this one, in my opinion, is what I tell my consultants, my teachers. I always tell them to graph the where x plus y equals 0. So notice if I move that x to the right, you get y equals -x. So at y equals -x, I better have slopes of 0. So, Chav, what does that mean? At the origin, 0. At negative 1, 1, 0. At negative 2, 2, 0. At 1, negative 1, 0. At 2, negative 2, 0. You guys see that? And then from there, I tell them to focus on a column. And you're going to see a pattern real quick. So if I just focus on the y-axis, so look, I'm at 0, 1. Well, 0 plus 1 is 1, so slope of 1. Doesn't have to be perfect. If I'm on the 0, 2, well, 0 plus 2 is 2, so steeper than that one. See? So now I'm going to go to 0, negative 1. 0, negative 1. 0 minus 1 is negative 1, so the same slope, the same steepness as the 0, 1, but negative. So negative. 0, negative 2, steeper, but negative. And I'll make it so steep. See, there it is. We took care of a column. Let's go to the x equals 1 now. At 1, 0, 1 plus 0 is 1, so make it the same steepness as this one over here. A little flatter. At 1, 1, that's 1 plus 1 is 2, so make it the same steepness as this one right here, the one on the y-axis. And then at 1, 3, well, at 1, 2, that slope is 3, so make it steeper. See? I exaggerated that one. Not so. There we go. All right. Now I'm at, let's see, where am I at? I'm at 2, 0. 2 plus 0 is 2, so make a slope of 2. I hope that you're noticing something. So all these slopes right here, check it out. Let me go over here. All these slopes right here along this line are going to be a slope of 2. Do you guys see that? Because at this point, that's 3 minus 1. So all these slopes should look more or less the same steepness, slope of 2. All these slopes right here should look more or less the same slope of 1. Hopefully you can start seeing the pattern. If not, no big deal. Just go one point at a time, guys. Go one lattice point at a time. So let's see, where am I at? 1, 2. I'm at 2, 1, so that's the slope of 3. And then 2, 2, that's the slope of 4. So you can already see that these slopes are just getting steeper and steeper. 1, 2, 3. I'm at 3, 0, so slope of 3. 3, 1, that's a slope of 4. Okay, now I'm at, let's see, 1, 2, 2, negative 1, that's a slope of 1. And then this is a slope of 1. That's 1, 2, 3. 3, negative 2 is a slope of 1. So you can already see, and this is going to be a slope of 1. So all these, so let me go back, you guys can see. Don't be a robot, don't try and be fast, just go slow. All these right here have a slope of 1. I tried to make them all the same steepness. I kind of messed up a little bit with that one, but that's fine. All those right there have a slope of 1. Notice, here's a general observation. Anything above this line, the y equals x, negative x line, all those have positive slopes. Guess what? All these below the y equals negative 9, what type of slopes do you think these are going to have? Negative, because on these right here, the y outtakes, like, it's below the value when you add them up is negative. Do you guys see that? Just go slow. If you don't see it, just go slow, one at a time. I'm at negative 1, 0. Negative 1 plus 0 is negative 1, so make it a slope of negative 1. Negative 1. And all these slopes are really, these are gonna be together perfect. Look at that. Almost perfect, like in synchronous. I love it. If someone were to tell you to draw a slope field going through the point negative 2, negative 1, that's just a linear line. Look at that. You just follow the pattern. That's just a linear line that goes through there. If you have a point going through here, it's going to go, and then you have a diagonal asymptote of y equals negative x. These are like wind currents, right? Like imagine a particle. If you're a particle, where would you go? Well, you would follow the direction of that wind. Let's see, negative 1, negative 1, negative 2. So slope of negative 2. Let's see, negative 3. All right, negative 2, 0 is the slope of negative 2. And then negative 2, negative 1, negative 3. And then negative 4, more and more. And then I'm at negative 1, 2, 3. Negative 3, 0, so negative 3. Negative 3, 1, negative 4, so more steep. And then this one over here in the corner is the steepest. And then 1, 2, 3, negative 1, negative 4. Oh, no, negative 2. All right. Your steepest All right, so look how this curve looks. I left out one point. Your steepest, most negative point should be the one that's furthest away in the bottom left-hand corner. The steepest, most positive point should be the furthest away at the upper right-hand corner. You guys see what's going on? Cool, right? And that's about as hard as it gets, guys, because we're not doing three-dimensional stuff. 1, 2, 3, 1. So -2. Okay. There it is. Number 4. Number 4. Here we go. 2x. Right on the y-axis, you should have slopes of 0, 0, 0, 0, 0, 0. Right on x equals 1, you should have slopes of 2. Right at x equals 2, you should have slopes of 4. Just make it steeper. Right at x equals 3, you should have slopes of 6. Just make it steeper than the previous one. At -1, make slopes of 2. Make it the same steepness as x equals 1, but negative. At x equals -2, make slopes of -4. Just make it steeper, but in the negative direction. At x equals -3, make it steeper in the negative direction than the previous one. And there it is. If someone asks you to find a point, to find a curve, I hope that you would tell them that all these curves, to me, look like parabolas. If they tell you to give me a specific curve, and if they tell you, depending on where the point is, that's where you follow the path, right? Pretend these are like wind currents. You go, see? If your point is way over here, then you're going to have a fat parabola. If your point is closer to the y-axis, then you're going to have a skinny parabola. And you can see how this is why, by the way, I don't know if you guys know this, but if you want to be a weather person takes calculus and differential equations for their undergrad. So the weather person you see on TV, they took calculus just like you guys. And you can see why, because of this. All right. Plus all the weather software is super advanced too, right? The Doppler radar and all that. All right, number 5. dy dx equals y minus 1. Right at the y equals 1 mark, you should have a slope of, so that's the first thing I would do. I would just plot the slopes of 0 first all the time. So go to y equals 1 and 0. 0, 0, 0, 0, 0, 0, 0. Because it's depending on y, and y at that value is 1. 1 minus 1 is 0. Guys, this is not difficult. You should have it in your brain. Something should be telling you, at the very minimum, everything above this line is going to have positive slopes. Because look what dy dx is. It's y minus 1. Do you guys see that? Everything below this line is going to have negative slopes. So you should at least be thinking like that, guys. So here we go. At the y equals 2 mark, my slope is 1. It doesn't have to be perfect. Just make it positive. Positive slopes like that. See? At y equals 0, at the x-axis, 0 minus 1 is -1. So make it the same steepness as what you have up there, but negative. So -1, -1, -1, -1, -1, -1, -1, -1. At y equals -1, you're going to have a slope of -2. So make it steeper. At y equals -2, you're going to have a slope of -3. So make it even steeper in the negative direction. And there it is. You got another one. All right. All right. This one here, there's been so many fights on this because, but I'm going to tell you what the consensus is saying, what the professors are saying. If you have undefined slope, you see how x is 0 here? X is 0 makes dy dx undefined. Some situations, some professors, it just depends who you talk with, are going to tell you to make tangent slopes like vertical lines, because that's what undefined slope means. College Board, the exam that you're taking, do not put any slopes if it's undefined. zero slopes. And there's so many discussion boards. Some professors say yes, some professors say no. If you're undefined, do not put a point. Do not put a tangent mark. Does that make sense? So we're going to leave x equals 0 alone. So no points on the y-axis. Okay, that's where x equals 0. So no marks there. All right. Let's see, where is this 0? Wherever the y value is 0. So all on the x-axis except at the origin. Except at the origin. Because you can't divide by 0. Do you guys see what we did? Okay. I'm just going to go a point at a time. Everything in quadrant 1 better have a negative slope. See, because it says negative in the front, but x and y are both positive in quadrant 1. So 0.11, negative 1. Okay. 0.12, negative 2. Because it's 2 divided by 1. Do you guys see what we did? I'm still on the x equals 1 column. I just go a column at a time. That's how I do it. My habits don't have to be your habits. I just think that's easiest. I'm going to go to 1, negative 1. So that means I'm going to have a slope of 1. I'm going to go to 1, negative 2. So I'm going to have a slope of 2. So let me make this one better. A little flatter, and then this one steeper. And there it is. That's my x equals 1. Now let's go to x equals 2. I'm at 2, 1. So that's going to be a slope of negative half. So make it flatter than the one before. So there it is. Because it's 1 divided by 2. Remember? And then I'm at 2, 2. So that's a slope of negative 1. There it is. I'm still going. So now let me go quadrant 4. 2, negative 1. So that's going to be a slope of positive half. So a little flatter. 2, negative 2. So that's going to be a slope of positive 1. Sorry. There it is. Okay, now I'm at x equals 3. I'm at 3, 1. So at 3, 1, that's 1/3, negative 1/3. So make it flatter than before. And at 3, 2, that's negative 2/3. So flatter than the one up there, but not as flat. And there it is. We finished quadrant 1. Let's see. Quadrant 4. I'm at 3, 1. 3, negative 1. So it's going to be a positive 1/3. And at 3, 2, that's a positive 2/3. So there it is. A little bigger than the one. There it is. We finished quadrant 1 and 4, guys. Go to quadrant 2. I'm at negative 2, 1. So that's going to be a positive 1/2. Sorry, it took a while. 1/2, so a little steeper. A little flatter, sorry. I'm at 1, 2. So that's a slope of 2. There it is. Negative 1, 2, sorry. I'm at negative 2, 1. So that's going to be a slope of half. Negative 2, 1. Bam. What was this one? Negative 1, 1. Oh, that's the slope of. Let me make this one better. Boom. That one's deeper. There we go. Negative 2, 2. That's a slope of 1. So, bam. All right. Negative 1, 2, 3. Negative 3, 1. That's a slope of 1/3. Negative 3, 2. That's a slope of 2/3. And there it is. We got quadrant 3. One more quadrant. Negative 1. Negative 1. That's going to be negative because of the negative on the outside. So slope of negative 1. Slope of negative 1. I guess you can let this point help you out and you can see the slope. Negative 1, 2. That's a slope of negative 2. Negative 2, 1. That's a slope of half. Negative half. Negative half. There's a negative right here. Negative 3, 1. That's a slope of negative 1/3 or negative 1/3. Negative 3, 2. That's a slope of negative 2/3. I missed one in the column here. 1, 2, 1, 2. Negative 1. There it is. So hopefully we're starting to understand what's happening here, guys. The way this looks, you have a vertical asymptote at x equals 0. See, sometimes they're defined, sometimes they're not defined. The way it's looking. All right. I think we are beast enough. Let's see. Match a slope field for the differential equation. The sin x one I think is the easiest. Which one's the one that's looking like it's going up and down, up and down, up and down? C. Number 7 is C. Do you guys see that? X minus y. Here's how I would do that one. Here's what I tell everyone. What's tough? I don't know. I can't tell. If you set this equal to 0, you get a line y equals x. So look for slopes of 0 on the line y equals x. And look at that. I see it right there. Do you guys see it? So this one, the answer is D. Hopefully you guys can see that. Look at number 9. Are you influenced by the letter X? No, you're never influenced by your X. Plus, in real life, you should not be influenced by your X. Their X is for a reason, guys. No, for real talk. So, which one looks like it's not affected by the X? Yeah, letter A. Look, if you go up, look, if you go left to right, look how that slope doesn't change. See? So, letter A. So, that one's letter A. Letter A. All right, and then the last one is just an X. So, that one looks like B. Look, it's not affected by your Y. So, if you go up and down on letter B, the slope stays the same. So, that one's B. Do you guys see how we did it? Yeah, yay. And look, I want you guys to notice everything in quadrant 1 and 4 is positive as is such. Everything in quadrant 2 and 3 is negative as is such, right? As it should be. So all things are good. All right. Now let's see if you guys try. You guys match these slope fields. Try it out, guys. Give it a shot. Give it a shot, Ramos. Yeah, I listened to you guys. You guys said that you guys want time to do it on your own, and so here it is. I'm going to call on a random individual. Relax. It's not a high pressure situation. Kendra, what does number 11 look like to you?
I have no idea.
No, yeah, you do.
No, I'm being so serious right now.
Is it affected by the letter Y?
I don't know.
Well, is there a Y in it? No. So you're not affected by Y. So that means if you go up and down, you should see the same curves all the time, the same slope. Can it be A? It can't be A. Can it be B? Can it be C? No. Can it be D? No. Oh, look at this one. Can it be B? Yeah. Look at how right there it looks like there's slopes of 0. Oh, that looks like x equals 2. Oh, look at that. Half of 2 is 1. 1 minus 1 is 0. So what's the answer to number 11? B. Do you see how we did it? Okay. Do you see the critical thinking, the analyzing? Okay. Ms. Ramos, hook me up with number 12. Heck yeah, it is. Why do you think it's C? It's only affected by the Y? Perfect. So, guys, did you guys hear what Ramos said? She said, in so many words, she said everything above the x-axis is positive, everything below the x-axis is negative, and that's because that's where the y values are positive above the x-axis, and the y values are negative below the x-axis. So, do you guys see that? So, she just said that it's only affected by y, so x's don't. This is Chavez. Yes, sir. Does that make sense or no? Okay, so there we go. Cepeda, hook me up with number 13. Let's see, A. Tell me why.
Honestly, I don't know, I guess.
Okay. No. Look, don't guess this. Look at this. Ready? See how there's a negative there? Look, this is how easy it is. Pretend that negative wasn't there. In quadrant 1, x and y are always positive. But because I have a negative in the front, in quadrant 1, my slopes are always going to be negative. Look, those are positive slopes. Can't be that. Those I see positive, but I also see negative. Can't be that. Well, I already said it can't be that one. And look at this. Everything in quadrant 1 on letter D is negative. Well, yeah, because X and Y are both positive, but there's a negative in the front. Look at quadrant 2. Everything is positive. Well, yeah, because X is negative. Positive divided by negative is a negative, but then you have a negative in the front. Negative times negative is a positive. Do you guys see that? So it's all about patterns. You just got to know patterns. And there it is. So question number 13, the answer is D. Stella, you're going home. All right. Does that make sense, guys? So I'll say it again. Check it out. Everything in quadrant 1 is negative, as it should, because there's a negative in front of that X over Y. X and Y's are positive in quadrant 1, but when you put a negative in the front, that means I'm going to have negative slopes. Do you guys see that? And they're always negative in quadrant 1. See? And Chav, how else can I tell? I mean, I guess you could also like hold the Y steady and make the X larger and larger and see what happens. You could always do that. Or vice versa, hold the X steady and make the Y, like mess with the Y values and see if it's getting steeper, the number, or not. Does that make sense? So number 13 is letter D. Cool or not cool? Okay. All right. Last one, number 14. Lopez, hook me up. Oh, Mia Lopez.
Well, I think I did, like I said, equal to 0.
Yeah, that's what I would do.
And then move the y over.
Yeah.
So x equals negative y.
Which is what letter? A. Yeah. You said X equal. I would have said Y, but that's fine. It's the same. It's the same. You found it. Yeah, there it is, guys. So the way I think it's easy, this is just what I think is easiest. You don't have to do what I think. I would set that equal to 0, and then I would say, oh, okay, I know how this line took because we all took algebra. And notice, boom, 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 boom. At y equals negative x, there's slopes of 0. Do you guys see that? Cool, right? All right. Don't worry, guys. We're almost done. This one right here from the 2008 course inscription, we'll do it together. The slope from a certain differential equation is shown above. Which of the following could be the specific solution to that differential equation? Do you see parabola? I'm not circling that. That's the answer. I'm just saying. Do you see parabolas on that slope field? Out. These are called exponentials. Y equals e to the x. And it looks like this. E to the x looks like this. Do you see a positive y equals e to the positive x there? No, out. There, look, it goes against the slope field, guys. There's no way it could be that. This one right here looks like this. Let me show you. E to the negative x. That one looks like that. Does it look like you have negative slopes in there? Out. Does it look like it goes up and down, up and down, up and down like a sinusoid? Out. The only one that it must be is ln of x. Ln of x looks like this. Let me show you. It looks like this. They didn't draw the slope field here in the bottom, but yeah, that matches. That matches. There it is. There it is. All right, you guys try. Number 16. Give it a shot. Yeah, I listen to you guys. No, well, it is, but not the way a wave does it.
Oh, the little like that.
All right, here we go. Does it look like it's a sinusoid? Now be careful. A sinusoid look like this. Up and down, up and down, up and down, up and down. It is going up and down, but is it wiggling like a sinusoid? It's not wiggling. It's not going sinusoidal. Does it look like it could be a parabola? No. Does it look like it could be a cubic? Yeah, it definitely looks like it could be a cubic. Look, guys, that's what it looks like. Cubics look like that. And then it's not an LNX. So there it is. It's letter D. It's a cubic. All cubics look like that if it's just a simple third power. All power threes look like that. All right, last one. This is from a real AP exam, the 2016 one. Let's see how much time we got. Yeah, we got time. On the axis provided, sketch a slope field for the given differential equation at the 6 points indicated. When they give you this, you're only... We're not teaching to the test, but, okay, I'll just tell you. I don't think they're going to give us one of these questions this year for free response because this year the free response questions are on booklets, and I don't see them putting this on a... I mean, maybe I'm wrong, but it's still good to know. We should do this over and over. You should practice. Hope and pray that they do give us one because usually this is the highest scoring one, usually. So hope and pray that they give you one. I don't think they will, but hope and pray that they do. All right, first thing I would do, they want me to sketch where is the slope 0. The slope is 0 as long as y is 0. So that means on the x-axis. 0, 0. Do not put a 0 at the 1. They don't put a point there. Plus, you're undefined at 1. Yeah, you're undefined at x equals 1. I should say that. Okay, next. What about the next one? You only have 4 points left. You can, if you want, write in here. You can write dy dx, and the readers will just ignore it. And I'm looking at 0, 1. So 0, comma 1. And I'm just going to go 1 squared over 0 minus 1. And that's a slope of -1. Doesn't have to be perfect. -1. The readers are not going to be like, oh, is this really a slope of -1? Just use, they're not going to look at it. But just use this as a reference. See, 1, 1. So just make it aim towards that, and you're good. All right. I'm going to go up to 0, 2. So here it is, dy dx. And you don't have to write this down, guys. If you see the pattern, you're fine. 0, 2. That is 2 squared over 0 minus 1. So 2 squared is 4. And then because of the bottom, it's -4. So -4, just make it steeper. And there it is. We're not done yet. We still got 2 more. Let's see. Let's see if we can do this without having to write anything. At 2, 1, the 2 is an x. The 1 is a y. 1 squared is 1. 2 minus 1 is 1. So 1 divided by 1 is 1. Same steepness as the one you have in the y-axis, just positive. And then at 2, 2, 2 squared is 4. 2 minus 1 is 1 again. So you're going to get a slope of same steepness as the other one, but positive. And there it is. Do you see how we did it, guys? Okay. And I love this question here, letter B. It says, we're going to go slow. Let f of x be the particular solution to the given differential equation with the initial condition 2, 3. This is the initial condition. That's a point. So write that down. Write an equation for the line tangent to the graph at x equals 2. Use your equation to approximate f of 2.1. Okay, they're asking 2 things. They want a tangent. What do I need for a tangent line? Point and slope. You already got the point. The point is 2, 3. I have the slope. You can either, they don't have it there, but you have the slope, just not directly. So here it is, dy dx at 2, 3 equals, and then just plug it into your equation for slope, dy dx. So let's see, 3 squared over 2 minus 1. You don't have a calculator, guys, so you're going to have to do this by hand. What's 3 squared? 9. So 2 minus 1 is 1, so there it is. The slope is 9. I guarantee you just the slope is a point, probably, I don't know, I can't remember. And here it is, y minus 3 equals 9, parentheses, x minus 2. Done. That's the tangent line. Cool or not cool? Now what am I going to do? I'm going to use that to approximate what? F of 2.1. So here's how you do it. Guys, by the way, if you're scared that you're going to make a mistake, I'm going to tell you where to stop. Here's where you stop. I'm going to go F of 2.1 is approximately, I would like for you to put the approximate symbol, but if you don't, that's fine. You'll still get the credit. 9 parentheses 2.1 minus 2. I'm just plugging in 2.1 for the x plus 3. If you're scared, Can you leave it alone right there and get full credit? Yes. If you're scared, matter of fact, if you're prone to accidents, leave it alone. If you're prone to making accidents, distributing and all that, leave it alone. All right. But right now we're courageous, so we're going to do it. So let's see. Now it's safe to put an equal sign because all you're saying is this equals something, right? 9 times 2.1 minus 2 is 0.1 plus 3. 9 times 0.1 is just 0.9. And when you add it to 3, that is 3.9. Done. Yay or nay? All right. Here's what we've been doing all week. This one right here. Letter C. Find a particular solution. Y equals f of x is a given differential equation if f of 2 equals 3. All right. So dy dx equals, what was it? Y squared over x minus 1? Y squared over x minus 1. The first move you should always do. If you don't do this first move, you're not going to get credit. And because I know the reason they do that is because they want to make sure that you're, okay, because they're separable differential equations, that's why. The first move, y's with the y's, x's with the x's, always. Yes or no? Okay, divide by y squared times dx. dy over y squared equals 1 over x minus 1 dx. We'll stop right here and we'll continue this in when we see each other again next period. Here we go, guys. So we said find a particular solution to y equals f of x as a given differential equation with the initial condition f of 2 equals 3. So this is my initial condition. And we already said dy dx equals y squared over x minus 1. The first move is to get the y's with the y's, the x's with the x's. If you don't do that first move, you're going to lose points. So now I have it looking like this. And now you're going to go bam and bam. You're going to take an antiderivative on both. See? So I'm just going to rewrite it so it's easier for us to see. All right, here we go. So I have, let's see, add 1, divide by that number. So negative 1 over y equals ln, absolute value of x minus 1, close it, plus c. It's only an ln when you have a linear expression in the denominator. There it is. Everything's good. I'm going to use this 0.23, and no demerit. You're going to make me yawn. I'm going to use this 0.23 to figure out what c is. So I'm going to go negative 1 over 3 equals, now I want to yawn, ln 2 minus 1 plus c.
That's a demerit, sir.
Yeah, no, you guys made me yawn, man. All right. Well, she started it, and then, yeah. All right. This is ln of 1. We got to at least know at the very basic, guys, like this. ln of 1 is equal to 0. We should know that, right? ln of 1 is equal to 0. ln of e is equal to 1. So c is negative 1/3. Man, I should have put more space here. All right, here we go. So I'm going to start right here at this one. Negative 1 over y equals ln. I'm trying to think if I leave it absolute. Yeah, leave it. Absolute. No, you don't need the absolute anymore, guys, because well, you can leave it, but you don't need it because this will always be positive with our current conditions. X minus 1 minus 1/3. Then my next move is turn everything into a positive. So I'm going to write it right here. 1 over y equals 1/3 minus ln of x minus 1. My next move, delta does it like this. I actually don't really like it. I'll tell you the way I would have done it a little bit. My next move is to put it all over 1 and flip it. Y equals 1 over 1/3 minus ln of x minus 1. And there it is. If I check it, if I plug in a 2, ln of 2 minus 1 is 0. 1 divided by 1/3 is 3. And there it is. It works. I would have done it this way. I'm going to write it in blue. I'm going to write it in blue over here where I have a lot of space. I would have done it like this. 1 over y equals 1 over 3 minus, and then multiply this by 3 over 3. 3 ln of x minus 1 over 3. So then you read 1 over 1 equals 1 minus 3 ln of x minus 1 over 3. And then flip. Y equals 3 over 1 minus 3 ln x minus 1. That's how I would have done it. But whatever. And that's it. We're done. How do you guys feel? Do you want to look at the points, or you guys just want to go right to the delta? All right, go right to the delta, guys. We're done. Have a good day.